ఇప్పుడు వస్తుందో చూడండి, ఇప్పుడు కొద్దిగా చెప్పండి. ఆన్ చేసిన, యూజ్ చేసిన, ఇప్పుడు బంద్ చేస్తున్నా. ఇప్పుడు
Raju, can we start?
Yes, sir.
So,
Hello.
Aparna ma'am, you
Sir,
can introduce the guest of the day.
okay.
Hello.
CRK still time is there.
Sir. So we'll start at 10 o'clock, sir, because we have to share the link to participants.
Hello.
Okay.
Aparna.
Aparna ma'am, just hold on, ma'am. I think
Yes,
still
sir.
time is there, and another 5 minutes we will start off. Meanwhile, we can have a. Meanwhile, Murthy sir,
Okay.
I request you to have a formal discussion with Boruddin sir.
Yes, sir. Cheppan sir.
So how is the education, sir, in Malaysia? Like here it is up to 10 plus 2 plus degree 3 years. Boruddin sir, like education system in Malaysia is similar to India.
Burhan.
I think his speaker is off. Huh?
Yeah, Burhan. Yeah, please. Our professor is asking something. Kindly answer to him.
Sir, nothing, sir. Just I wanted to know the education system in Malaysia. Is it similar to our education system in India, like 10 plus 2 plus graduation plus masters? Not audible, sir.
Burhan, increase the volume.
Not audible.
To unmute from his side, sir.
Yeah. Just behind that red button left side, that mute is there, sir. Speaker. Yeah. That one. Correct. That only you have to unmute. Speaker. Besides red button, there is a speaker. Red button ki bazu mein, sir. Left side.
Sir, unmute your audio, sir.
Okay. Can you hear me?
Yeah.
Yes,
Fine, sir. Fine.
Yeah.
Just wanted to know the education system, sir, in Malaysia.
Education system in Malaysia, we have a primary school around 7 years, and then it continue with the secondary school another 6 years,
Sir.
and then we'll have like O level, okay, at that time. Then continue with the A level for 2 years, and then for computer science we have around 3 years for diploma program in our university. Then followed by 3.5 years for computer science, 3.5 years in university for the first degree. But then for the engineering, it takes 4 years because they have engineering council. So it must be more than 4 years. Then for master degree, 1 to 2 years, and then followed by PhD, 2 to 3 years program in our university. And it's likely same to other public university in Malaysia.
Is there any entrance examination, sir? Here, after 12th, there is an entrance examination for engineering stream.
Okay.
So, similar to that, is there any entrance exam in Malaysia?
Entrance exam, we don't have. If they go for the matriculation, or if they take A level, so no entry exam, but straight away they can enroll, providing they should have a good result in physics, as well as chemist and at mathematics, at maths. So they can enroll for our degree program.
So for quality purpose, they are following the ABET.
Yes, they are following the ABET, and we have Malaysian Academic Accreditation Council.
Oh, very good.
So we follow that. And however, if the student have like international baccalaureate,
sir,
it's baccalaureate, then straight away they can enroll to our university.
Good.
Of course, we have to have an English requirement, either IELTS or TOEFL.
Sir.
Yes.
I think somebody is sharing their screen. Murthy sir, I think you are sharing your screen. You can.
Yes, sir.
Everything screen, everything. Password 2020. Whose mail is that? MGIT Day2. Let's see. Stop sharing. You have to press, sir. Somebody is sharing their screen.
I'm not sharing my screen yet at the moment.
I think Murthy sir might be. Murthy sir, I think you can close your mail, sir. Murthy sir. Yeah, that is Murthy. Yeah, Murthy sir only. Yeah. Thank you, sir. Murthy sir. Thank you. So another 2 minutes we will be in live. So
How about the COVID pandemic in India now?
come again, sir. How about?
How is the pandemic, COVID-19?
Pandemic.
Coronavirus.
Situation is, I can say, the initial, this is actually the third month, sir. Somewhere on March 15th, we have started the lockdown process.
Okay.
So now it's already almost all 90 days are over. So 3 months is over. Now the people are well aware of the situation, what to do and what not to do. But irrespective of that, they are doing what not to do.
I see.
So, marketplaces are crowded. And being the second largest population of the world, they are finding it difficult to have that social distancing and norms and all that. So government support is very good. And
good.
So we are moving on. Now, hopefully we will come out of this with minimum damage, and every situation teaches us many lessons. So let us learn the lessons of this particular COVID-19, and this is the first time, in fact, actually all of us are moving from online, from face-to-face classroom teaching to online mode.
Good.
So we are progressing well, we can say.
Right, sir. Good morning, sir. Now the time has
yes,
that is
fine, Raju.
live session.
I will mute myself now.
Right. So all the participants, I request all the participants, please mute your audio except ma'am.
So I can mute?
Yes.
Yeah.
Over to you, ma'am.
Okay. Good morning and a warm welcome to one and all. I'm Dr. Aparna, Assistant Professor of English, Mathematics and Humanities Department. On behalf of the management, principal, heads of the departments, and staff members, I welcome each and everyone to this International FDP on role of machine learning and data science in AI. A special welcome to our esteemed guest, Professor Burhanuddin bin Mohammad Abu Baida, Faculty of Information and Communication Technology, University Technical, Malaysia, Malacca. Respected Professor Jaishankar sir, Principal MGIT, respected Professor Ramnamurthy sir, Head of the Department, Mathematics and Humanities, respected Professor C.R.K. Reddy sir, HOD CSE Department, fellow faculty members, and the enthusiastic participants.
Ma'am, video is off.
I would like to begin.
Your video is off, ma'am. Yeah, fine.
I would like to begin with one of the famous quotes of Shakespeare. Sweet are the uses of adversity. I repeat the line, sweet are the uses of adversity by Shakespeare. This line is apt for the present situation that we are able to spearhead with our learning and progress despite the pandemic COVID-19, which has shattered the world and created a havoc. We are able to meet on this common platform to be enlightened and enriched with the insights of the resource persons that we have for this FDP. The world has become smaller. Yes, it has shrunk, and yet we are honored and privileged to meet people from different corners of the world today, thanks to our science and technology. Yes, ladies and gentlemen, I welcome Professor Burhanuddin bin Mohammad Abu Baida, the Faculty of Information and Communication Technology, University Technical, Malaysia, Malacca. Professor Buranuddin, Associate Professor of Information and Communication Technology, FDMK, University Technical, Malaysia. Currently, he is the Director of University Technical Malaysia International Office. He received a diploma in Computer Science in 1995, Bachelor of Computer Science in 2002, Master of Science in 2009, and he received his doctorate degree in Computer Science in 2009. He is the former Biomedical and Engineering Research Group Leader in University Technical Malaysia. Professor Buranuddin played an active and dynamic role at all levels of development in FDMK, University Technical Malaysia. He was privileged to be one of the team members from Malaysia to set up Faculty of Computing and Information Technology, King Abdulaziz University, Rabat Kingdom of Saudi Arabia. Professor Buranuddin has rich experience in research supervision of undergraduate and postgraduate students. He has also been successful in receiving quite a few research grants. He has working experience with corporate sector, including Intel Technology, Rubber Industry Development Authorities, etc. His teaching and research interests focus on multiple criteria decision-making models, computational modeling, decision support system, optimization techniques, operational research, artificial intelligence, machine learning, soft computing, and healthcare informatics, etc. Professor Buranuddin was awarded the bronze medal in Malaysia Technology Expo 2009 for the product Web-Based Maintenance Decision Support System for Small and Medium Industries. Ladies and gentlemen, Professor Buranuddin received the silver medal in University Technical Malaysia Exhibition Expo 2015 for the product My Intelligent Vacation Planner application, and a bronze medal in University Technical Malaysia Exhibition Expo 2017 for the product Big Data Analytics Sentiment Analysis Prototype for Telecommunications Providers in Malaysia. Ladies and gentlemen, Professor Buranuddin loves to travel, teach, doing research, read, and also jungle tracking. So a hearty welcome to Professor Buranuddin, and we are privileged and honored to have you here, sir. Thank you very much for gracing the occasion. Thanks.
Thank you, ma'am. Thank you. Burhanuddin, sir. So now over to you, sir. So whole class is yours.
Okay, thank you very much. Assalamualaikum warahmatullah, and very good morning. Now even me get confused, want to say good morning or good afternoon, because in Malaysia now it's 12:35 afternoon, whereas in India now it's morning. So good morning and good afternoon to all of you. With this kind of online talk, as well as because of this pandemic COVID-19, so time doesn't matter. We can meet even we are very far, but we can meet easily. Is it clear?
Yes, sir.
All right. Thank you. Dear Chairperson, Chief Patrons for this webinar, me Professor Kavi Kiritri, Professor Dr. V. Malakunda Reddy, CVK Reddy, Professor Dr. Sri G Shamsuddin Reddy, Professor Ramana Murthy, and committee members of this webinar, dear Professor, Doctor, lecturers, students, and as well as all the conference or webinar participants, ladies and gentlemen. First of all, I would like to thank this webinar organizer for inviting me to deliver a very good talk today. And thank you for Prof. Ramana as well, because choosing me to take a part in this seminar, which is, I think, is a very good seminar for us, where in this session, I would like to present an important topic, which is very important nowadays, that everyone talking about IoT, about big data, about data science, and so on. So my topic today will be on data science and its applications. Okay, so shall I share my slide now?
Yes, sir. You can go ahead with your presentation, sir.
Can you see my slides?
Yes, sir. It is visible.
All right. So this is a talk about data science and its applications on one of the topic in webinar on role of machine learning and data science in artificial intelligence. And today I'm going to give a talk for Mahatma Gandhi Institute of Technology, and I am Associate Professor Dr. Burhanuddin bin Mat Abu Baidah from Faculty of ICT or Information Communication Technology, University Technical Malaysia, Melaka. I think I don't have to introduce myself further because just now Ms. Chairperson already share my detail. So let me go straight to the introduction to data science. Before we go deep onto the applications of data science, we should know what is data science actually. All right. Data science is, number one, is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. It is related to data mining, deep learning, and big data. It is a concept to unify statistics, data analysis, machine learning, domain knowledge, and their related methods in order to understand and analyze actual phenomena with data. And in data science, actually what we do, we utilize techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, domain knowledge, as well as the information science. So all this you can get a detail from Wikipedia. I have taken this from Wikipedia on what is data science means. And in fact, data science asserted that everything about science is changing because of the impact of information technology and the data deluge. Data science considered as a fourth paradigm of science, which is empirical, theoretical, computational, and now it's called is data driven. I have taken all this detail from Jim Gray, who is the Turing Award winner. So when we talk about the phenomena of this data, now there are many data in the web, and then we can use many techniques, including soft computing techniques like artificial neural network, fuzzy logic, or some optimization techniques like genetic algorithm to mine all this data. All right. Let us look at the paradigm data science, as I mentioned just now, in Industrial Revolution 4.0. Modern industry and advanced technology is adapting the Industry 4.0 paradigm, which is fostered by the Industrial IoT, which is stand for Internet of Things, where it's connecting intelligent physical entities to each other, where it will use a lot of sensors and it allowing complex equipment units to have embedded with these sensors and special modules or agents, providing connection to the monitoring center. Smartphones, nowadays everyone having a smartphones. So when they have a smartphones and it's connect to the internet, then it contribute in a similar way in a social networks, marketing, sales, and finance. All right. To summarize or to recap of this data science, we can see our this Venn diagram where we can see a combination of main component in data science. For data science, which is between a computer science, mathematics and statistics, as well as domain on business knowledge. So as I have mentioned just now, if you look at the technique that we use, there are many techniques in machine learning. So and we have many formula in mathematics and statistics. So when we use both of these, then we can come up with some important machine learning techniques to solve a real problem. But if we look at the traditional research, we can see that we use a lot of like calculator or other calculation or even we just use typewriter. But nowadays with smartphone, and then we have many sensors which embed into our handphone, then we can develop more robust technique to solve a real world problem. Let us look at the propositions of data science. Is it clear? You can hear me?
Yes, sir.
Everything is fine.
All right, thank you. All right, for the proposition of data science traditionally has triggered from ICT industries such as Cisco, Twitter, Google, YouTube, WhatsApp, Amazon, etc. If you can see now, young generation, they are very familiar with all these apps. And data science proposition is the transition from data, because when they use Twitter, they use Facebook, Google, or WhatsApp, people keep on pumping or giving or input a lot of raw data. So how can we use this all raw data to transform into the information? So this is where this data science comes. These industries means that the industries like Cisco, Twitter, Google, YouTube, WhatsApp, and so on have been traditionally focused on building efficient algorithms for getting good predictive models to forecast many things in future. In these industries, the approach is used for building soft sensors in the situation that collecting value of a response factors difficult or expensive to measure based on process variables sampled with high frequency but very cheap to measure. This is high frequency means that you want to upload the video into cloud, for example. So it's require space and so on. But once we have all that upload into cloud, then to measure is not a big deal nowadays. So in those situations, there is really no new scientific knowledge, for example, process understanding acquired. So only patterns, if we can see the patterns and so on, then we can come out with a good prediction. And it's so-called high-level knowledge extracted from low-level data. So we have low-level data, just raw data, but we can come up with a very high-level knowledge, very important knowledge to the people. But then now the issues is how we want to transform all these raw data into a knowledge, into the information, and so on. So there are cycles that we can see over here, where I have taken from sudeep.co website. First, we have to understand the business. For example, if I want to develop a system for healthcare, so first I have to ask relevant questions and define objectives of the problem that needs to be tackled. So either I go and see the patient, what is the problem that they have, or I have to go to the hospital, or I have to go to the medical doctor and identify the important relevant questions that can help doctor to make decision, or to can help the patient to reduce their pain, or to get diagnosed on their disease faster, and so on. Then once we identify we find out the related questions, then if we look at the database, there are many, we can see the column and row of data. For the row, maybe we have a record of every patient, but then if we look at the column, the attribute and so on, so there we can see how we can gather and scrape the data necessary for our project, where it's called data mining. Once we get this, we can mine all those data. What I can say, data in the cloud, like we can say like a gold or like a crude oil in the earth. So if the crude oil is there or the gold is inside the earth, but if we didn't dig it out, we didn't take it out, so it's we couldn't get the value of those data. So same those gold or crude oil. But then same goes to data. There are many data, raw data in the cloud, but then if we didn't mine and we didn't take the important attributes and come out with the analysis, then it will be meaningless to us. All right. But once we get the data, then we have to go for the data cleaning. This is a step 3. where we fix the inconsistencies within the data and handle the missing values, as well as we had to remove all the noise in the data. Once we do that, then we go on the data exploration, where from hypothesis about our defined problem, then usually we can analyze the data. So we can try to find the region of interest of from that data. For example, let's say in medical, we have taken the images from CT scan image, or from endoscopy image, or maybe we take from MRI the images. Then we can identify the region of interest that we would like to study. For example, we want to study on the cancer patient. So we identify the region of interest, and then based on that region of interest, if we can come up with the machine learning, we compare with other huge images that we already classified to images of stage 1 cancer, for example, ovarian cancer stage 1, ovarian cancer stage 2, ovarian cancer stage 3, and so on. So if we can identify the region of interest and we try to compare with the images that we classify, then easily we can classify or cluster that images into few groups. Next, if we look at step 5 on feature engineering, we select important features and construct more meaningful ones using the raw data that we have. Next one, we have that we can have predictive modeling. We can model or train machine learning models, evaluate their performance, and use them to make predictions. For example, if we have new images and then we manage to identify that image correctly, then it can be important data that we have to compare any new data. And next, about the data visualization. If we have a data and then we cannot visualize it in terms of graph, in terms of a graph like pie chart, histogram, and so on, so difficult for people to see clearly and make a decisions. Okay. So we want to know nature of data in IoT. All right. How it's related to my topic today on data science, because why I mentioned about IoT. Nowadays everything in internet, all right? So it's easier. Even my students, if they want to do a survey or collect data, so they used to use like Google Doc, Survey Monkey, and so on, to collect the data. So they just use the internet and then they blast the message, and they are able to get the data. And even I have other students where he has research on medical, for example. So he just use a sensor, for example, like ECG sensor and so on. So there is a wide variety of sensor types providing different types of signals. For example, spectra, chemical signals, or pressures. Even we want to check, for example, our car tire pressures. So if we can put certain sensor at the tire, then easily we can measure the pressures. All right. Other than that, toxic gas, for example, in a building, they have a toxic gas or burning smell. So if we put certain sensor, so easily we can identify, or any abnormal behavior at that particular time, as well as temperatures. For example, if we can put temperature sensor in our handphone or our device, so by periodic time it can transform or submit the temperature to the cloud, for example. So from that reading, we can identify, even we can see the pattern of dengue fever compared to high temperatures of COVID-19, for example. As well as for fall detection, for example, if we have elderly people at home, so if we can put any sensor to the device, and then we give to that people, so let's say our mother or father or grandmother or grandfather who is old at home, maybe more than 60 years, for example. So they are retired. They stay at home, and we are at the office. So if they fall at home, at least if we install that sensor at their body or at their handphone, for example, so when they fall, then it will give a signal to us so that we know that we are in emergency. So all this raw data needs to be analyzed and presented in a way that easily interpreted and that is useful to process engineers or useful to the medical doctors or managers and so on. If we didn't analyze those data, then it will be meaningless to us. We want to extract meaningful relationships that can be used to improve and optimize a process. So in fact, there are many statistical and mathematical tools are appropriate to analyze them, right? So, and then we can try to find the correlation between the factors. For example, if we have a data or attributes, then we can see what is different between male and female respond to that particular attributes and so on. Or by qualification, for example, for people who have diploma, how they react. People got degree, how they react. Master, how they react. PhD, how they react, and so on. Or maybe in terms of the age. So child compared to adult and compared to elderly or senior citizen and so on. So there are many things that we have in the internet that we can use to mine those data and transform into useful knowledge. Where you can see, as I put in this input for data science that I have taken in 2019, last year. This is the recent one, taken from daily infographic.com, that you can see in 2009. We can say that data has emerged to cope with the so-called data tsunami. All right, so we can call that data tsunami because for every second or every minute, for this data is every minute, every 60 seconds, we can see that 18.1 million texts sent in WhatsApp. Video viewed 4.5 million in YouTube. Apps download in App Store or Google Play, 390,000. Okay. Scrolling Instagram. Yeah, people just scroll. They go to Instagram, they scroll. So we have captured that in daily infographic. It's 347,000. You can see 87,500 people tweeting every minute. 1.4 million swipes in Tinder. 188 million email sent. I'm not sure in India because they use crores, million or billion. So in Malaysia, if million means that we have 60. Yeah. And you can see over here for Google, for example, 3.8 million search queries within 1 minute. All right. And Facebook, 1 million login in during 1 minute. So all this data we already have in the cloud. So the issues and challenges, how can we transform it into a data science and then try to mine those data using a very important techniques to identify for decision to identify values to a decision maker. All right. So now people talking about big data. When we call about data science, they talk big data, big data. So now big data or value in data, which is more important? So let me try to explain a bit about this. All right. First one, quantity of data does not represent their quality. We have to understand. I believe there are many researchers, many lecturers and students in this session. For the professor or doctor who has PhD, maybe you are well versed on this. But for the student, I would like to emphasize here that quantity of data does not represent their quality. So not necessarily if you have a big data, huge number of data is better, no. Moreover, the larger the quantity and diversity of data, the harder quality assessment will be. Number 3, data scientists must be involved in the data generating or collecting process and not adopt a passive role waiting for the data to come no matter. All right. So the first one is the science or engineering and structure of the process of product from which the data were collected is important. The second one, the collection process used to obtain data and prepare for analysis. And the third one, how the measurement were physically obtained. All right, if we collect data but we don't want to measure, we don't want to use all that column, for example, or all that field, for example, so it's the wasting. So if we want to collect data, if we want to conduct a survey, make sure we study and make sure that we collect the correct data. How we want to know what data should we collect? All it depends on the applications that we want to use. For example, if you want to apply in the university, then what kind of data that we need? If we want to study on the technical, for example, air conditioning maintenance work, so what kind of data that we should collect? So if that data is not necessary to us, so no need to collect, because how much data that we have is not important, but the quality of data that we collect is very important, where it can be used for many applications, as I have shown in my slide right now. Okay, so the applications of data science nowadays, there are many in e-commerce, where you can see they're trying to identify the consumers for e-commerce. So from the Amazon, for example, or from what I always use to buy product, okay, like books, I use Amazon sometimes to order books and so on. So if they look at the pattern, then they can identify what kind of book that I like and so on. So with that, they will recommend any products to me, and they will ensure that the probability of me to buy that product is high based on their analysis. And next, manufacturing. For example, application in manufacturing, we can see they try to predict potential problems in manufacturing so that they can reduce the downtime, and then they can have some kind of monitoring systems based on the downtime data that they have. So which machine should they focus to put more sensor and monitor, and which machine, for example, can produce high volume product, so they have to put more sensor to ensure that that machine can be used 24/7 without any shutdown. And if there are shutdown, so what is the emergency plan that they should have? Other than that, the automatic manufacturing units, maintenance scheduling, and anomaly detections, and so on. Other than that, banking, as I have mentioned just now, okay, they can identify fraud detection, okay, how many times that we log in. So if they can come up with a pattern, identify how many times that people log in and so on. So they can have some information or decision on fraud or malicious and so on. All right. And then on credit risk modeling, customer lifetime values, and so on. For the healthcare, nowadays it is booming for this healthcare, I can say, because there are many medical image that they have in the net. If you go, if in Malaysia, if we go to even public hospital, they already use electronics nowadays. So for example, our x-ray image, so they just upload the electronics without holding the hard copy. So once they have the in electronics form, then easy for us to come up with the analysis, and then we try to come up with the drug discovery, bioinformatics model, and so on. And then now for the transport, self-driving cars, you can see there are many in the market, especially in the western side. They have unmanned vehicles. So they enhance driving experience. They come up with the algorithm, how we drive, how we try to synchronize ourselves with the steering, with the gear, with the speedometer, and so on, with jet synchronization. And then they have smart traffic light system. So with the integration of this hardware, so they have good car monitoring system nowadays. Here in Malaysia, if you go to Putrajaya, then you can see we have a smart traffic light system where it controls the traffic for the light, red light, yellow light, and green light based on the queue of the car, and so on. As well as we can enhance this for the safety of passengers as well. Other than that, for finance application, for the customer segmentation, strategic decision making, as well as risk analysis. So this is the applications of data science, but not limited to these. Nowadays, they use for many things, including for the COVID-19, how fast we can detect how many PUI, for example, and PUS, person under surveillance and person under investigation, all using electronic or computer science, because all that data is key into a database. This is the example of data science applications that I would like to zoom on intelligent transportation modeling. So if you look at this intelligent transportation modeling, you can hear me, right? Do I have enough time? Or
Yes, you're having enough time, sir. You can, you can take your own time.
all right, thank you. If you can see over here, this is the usage of fuzzy logic, where they use this fuzzy logic in a signal traffic. Okay, so they come up with the membership function, and then with if and else statement, it come up with certain condition. For example, the time car have to move, the time car have to get ready to move, or the time the car had to stop, and so on. And as well as at the traffic light system, they install the camera and sensor. So once the car move at when the light is red, so it will prop the image of the car either in front or behind, and then it will identify region of interest, which is at the plate number. So it will take and then identify the plate number, and then straight away can submit to the authority. And then, of course, every car in Malaysia, if you purchase a car, it come out with the grant. And then nowadays in Malaysia, they don't give a hard copy of the grant, all in electronics. So with that plate number, they can compare the color of the car, model of the car. From that, we can identify the car is belongs to that owner, or the car been stolen, and so on. So very fast, it can come up with that analysis and supply the information to the police, and then police traffic can stop that car at the next stop, and so on. All right. Other than that, we can see there are multidisciplinary research involved here. For a researcher, I believe there are many researchers in this webinar. So there are researchers who has strength or expert in ICT or GIS, Geographical Information System, or GPS, as well as engineering people. They are good in road construction, building, and so on. So they know where should they put all that sensor on the road, and so on. As well as for the manufacturing car, for example, Toyota, Honda, Kia. So nowadays they are trying to come up with the smart car, as well as we have to know human factor as well, their fitness, their attitude, discipline, and so on. So the combination with this, together with the environment to reduce the pollution and so on, so we can come up with a very good system for transportation. All right. So all this will be in data science, and in order to ensure that this application is successful in IR 4.0, so we have to consider few things here. The first one, we should have a powerful storage or cloud or server, a powerful server that can store huge number of data, including audio, video, images, and so on. As well as that server must have a good computational facilities. The processor must be good processor, and it can process in parallel processing, and it can easily display the infrastructure. For example, if let's say I have 10 hard disks in one server, so it can easily show to me which hard disk is good, which hard disk is faulty, the utilization of every hard disk in that hard disk. So the mirroring, when it does the mirroring between the hard disk and so on, where this all can give very good statistical thinking strategies for the manager to buy the server of choice for us, and so on. And of course, this is about the teamwork. For successful data science application in industrial revolution 4.0, teamwork is very important. And this is the basic domain knowledge of problem that we have to solve. Those days, in the traditional ways, we can say that if I'm working on the network, so if you ask me about the hardware, what I will tell, this is hardware or server problem, is not related to the network, I don't know, right? And then same goes to the software side. If it's related to the software, and then the hardware people will say, this is not my problem, those days. But now, in order to ensure that we have a successful data science applications, so we have to work in team. This is our problem, that we have to sit together and focus the change from deductive to inductive, means that from the theoretical that everyone have, and then to the exploratory reasoning. And at the end, whatever we have done is explanatory, means that whatever we have done by itself, the documentation that we have, and then the analysis that we have, it will tell the story about our performance, production, and so on. So what I can say here, let the data speak for themselves. Okay, do not select in advance the variables to be used, but compress them and prove later if desired to have. All right. So all this is about the data science, but then if we look at the number 6 and number 7, it's more on data analytics. Okay, so for data analytics, they should have a programming skills and good knowledge of optimization algorithm. What kind of algorithm we want to use? Either we want to use genetic algorithm, we want to use end colony optimization, we want to use eyes or artificial immune system algorithm, or we want to use machine learning techniques. For example, we want to use artificial neural network, or convolutional neural network, or deep learning, or we just want to use the classical statistical tools. This is applicable for passive applications. So we have to have that kind of programming skill. Where I believe that in India, we have many programmers where they have a very good programming skills. They have many mathematicians and statisticians in India. I used to work in Intel technology in Penang, one of the state in Malaysia. So when I use in Intel, this is the US-based company producing microprocessors and computers, Intel Technologies. where during my assignment in Intel, I worked there for 6 years, and we used to hire many programmers and mathematicians from India in year 2000 until 2006. Many Indians likes to come to Malaysia. They work in the same factory with me. They have one department where they come up with a programming for the processor and so on. Those days, but nowadays, the less people from India coming to Malaysia. Maybe they have that kind of good salary in their own country in India, or straight away they go and work abroad in US, UK, and so on. So once we have this kind of skill, I mean programming skill, with ABAC, for example, advanced business analytical model programming skill, so we can demand for very high pay. And nowadays we are talking about real-time analytics. Why we are talking about real-time analytics? Nowadays they want, if they want data and then they want to make decision must be very fast. For example, if I ask you to give me a data about Gandhi Institute of Technology, okay, Mahatma Gandhi Institute of Technology, for example, I ask, can I know the enrollment of this Mahatma Gandhi Institute of Technology? Do you have a postgraduate here in this institute? Postgraduate students?
Yes, sir. We are having PG students also.
Yeah, so you have postgraduate students. So if I ask you, sir, in June, I ask you now, how many students you have PhD, how many you have master, how you have undergraduate. But then you reply to me, you give me a data, sir, I have PhD this amount, master this amount, but the data is 2000, year 2000, you know. So it's really meaningless to me. You give me data about Mahatma Gandhi Institute of Technology enrollment, but data is in year 2000. So it's meaningless, because now already 2020, right? So if I ask you what I expect current now. So that's why we really need nowadays on real-time analytics. Why? Because we want to make decision faster. We want to have a fast decision making, and we want to perform time critical analysis almost immediately after the data are generated. This one I've taken from the source Ferrer paper. This is a recent paper in 2020. You can try to find his paper using Google Scholar, where he has mentioned many things on successful data science applications. If you look at these slides, number 1 to number 5, is talking about data science. But then number 6 and number 7 is more on data analytics. So if we have a student over here, probably they confused. What is the difference between data scientist and data analytics? Data analyst. How to differentiate that? Okay. So this is the question that I think probably in your mind that you want to know about it. Okay. So if I have given the link, in fact, this material I have emailed to Prof. Ramana as well, and the organizer, so you can have it. And I have given the link. If I open this link, it gives a discussion about what is a data scientist and data analyst. Can you see this website?
Yes, yes.
All right.
I mean, web link is visible, sir. I think site is yet to come on the screen.
Okay. Can you see the website?
No, the
No.
only link is coming. Link is
Okay.
visible.
Okay. 1 second.
Is it visible on your screen, sir?
Yeah, visible in my screen. Let me share. How about now? Can you see?
Yeah, slides are coming, sir. No.
Can you see this link?
Your slide is coming, sir. Your first slide has come now.
Oh, you cannot see the link.
No. We have again, your first slide is visible. I think you have selected your first slide.
Oh, okay. 1 second. How about now?
Yes.
You can see the link.
Yes. Very
the
much.
web-
Data
web-
scientist versus data analyst.
Oh,
Yes.
okay. Thank you. So I'm not going to show you the journal paper and so on. This is just the discussion between people on data scientists and data analyst. Okay. So people asking about why is they are different, and then you can go and see here for students. You can see what is data scientist, what is data analyst, and we want to know why is there similarities. A common job description, and as well as we have to know what is their differences, because we want to know their job description between one another, so that they know their role in very detail. Okay, so you can scroll down. You can see data scientists, they involve more on the techniques. Okay, they have techniques, so they mention what kind of algorithm to use, and then they try to enhance the algorithm and so on. Whereas for data analytics, they use all that algorithm or the techniques, and they come up with the program. So here, data science can be described as a field of automatic statistics in the form of model that, that aid in classification and prediction outcomes. So they are studying, is it good to use Python or R? For this kind of problem, you should use MATLAB, or we should use SQL, we should use Jupyter Notebook, or what kind of algorithm, what kind of modeling that we use. So that will be a discussion by data scientist. Okay, we want to use random forest, or we want to use logistic regressions, we want to use k-means for clustering, we want to use k neighbors, nearest neighbors, in neural network for classification or regression and so on. Okay, so the main function is they will meet the stakeholders, then find what is the business problem, then how they want to pull data, what kind of data that they want to pull, and then they come up with the infrastructure, what kind of software, what kind of algorithm, and so on. Whereas for the data analysis, the data analyst, they share similar title with business analytics. Okay, they come up with the business intelligence analyst and Tableau development, or they use Microsoft Excel or Tableau or RapidMiner and so on. You see, they use SQL, Excel, Tableau. So what kind of chart they should produce, okay, and so on. Okay, this is the similarities, and now you can see the difference. Some of the main difference revolve around automation of the analysis. Data scientists focus on automating analysis and predictions with algorithm, as I mentioned, using programming language like Python and so on. Whereas data analysts used stationary or past data, they use a real data, and in some cases they create predicted scenarios with tools like Tableau, SQL, and so on. All right, now I back to my slide. Can you see my slides?
I
No,
think it will take some time. I think just still the previous slide was visible. Previous slide in the sense the link whatever you have opened, that was visible. That is visible now.
no problem, give me 1 minute. I will share back
Yeah.
my previous
Yeah.
let me control. You can, my voice is okay, right?
Yes, yes. Voice.
Okay.
Yeah. Now slides are visible, sir. Yeah.
Okay.
Now the link
Now,
slide is visible.
all right. Now let me talk. Maybe only 5 minutes. I'm sorry for the time that I'm going to take. Only 5 minutes. I'm going to talk about the issues. So now current issues, data science on related to COVID-19, which is this is the pandemic effect the whole world, that you can see number of cases are increasing. Okay, so this one I have taken from McKinsey and Company. This is briefing note on June 25th, this week, June 25th. No, last week. Yeah, last week on Thursday. It's released on this COVID-19 related issues. All right. Let me share the link. Okay, this the actually I already attached this document to the organizer, and you can have it. Let me open. Can you see my screen?
Yes, yes, yes.
Okay, you
McKinsey
can.
and Company.
Yes, you can see this is McKinsey and Company. So we can see that every industry nowadays is adapting to life during a pandemic. And new McKinsey research examines the implications of 6 sectors in this article. All right. So you can read this article, which is a very interesting article about the recent issues in the world. And one of the critical findings that consumers are returning to big brands they know and trust. Okay, so it's important, especially if you are a PhD student in the university. So please be extra careful. Those days when we conduct the research on medical, for example, so we are academician in the university. We come up with the analysis, our findings, and we conclude certain things, and we upload to a journal, right? But then medical people, they are very busy with the diagnosis of the patient, with the hospital work, and so on. Sometimes they don't have enough time to see or scrutinize our article or our papers. But nowadays we have to remember, everyone looking at our paper. If you write your title COVID-19, or in keywords you write COVID-19, everyone will be looking into our papers, especially medical doctors, right? We have to bear in mind that when they look at our papers on COVID-19, for example, we produce a certain conclusion, so they will read. So every single analysis that we have done, they see any any problem or any mistake and so on, then straight away they will take action and so on. So we have to be extra careful nowadays. Even my student, I have student from India in Kadanaka in India. He is working on the lung cancer images. So recently he published. He said that he identified the pattern of this COVID-19, which affect the lung, is very much different compared to others like dengue and so on. So he come up with the very good findings. But then when he wants to publish, when he wants to publish, he we are worried. We are worried, and then I told him that you on hold first, on this, and later he will publish once the uh, when we have a right time, then we will publish on these COVID-19 papers. If we look at here, we can see the high risk financial, low risk financial, and so on. And then we can see at the bottom in x-axis is less affected and more affected region. And there are many factors, right? So all this taken from the net, and we can do analysis on this. Okay. I think that's all my presentation, and let me open my slide again. 1 second, let me open my slide again.
So, if your presentation is over, shall we go for the audience questions, sir? Any queries from the audience, or you want to give some concluding slides?
Can I open my concluding slide?
Yes, yes.
Yeah, please.
So your presentation is over, sir?
Hello? Hello?
Sir, like this.
Hello?
Yeah, we're hearing you, sir. We're
You're
hearing
hearing?
you. Yes,
Okay.
yes.
Let me open my slide.
Yes, yes. Yeah, slides are coming now. That the sixth slide is visible. Data science. Yeah, last data scientist and data analyst slide is now visible. Meanwhile, Ratna,
Yes, sir.
so you can take the questions. If any
Yes,
audience are having any queries, just introduce them to sir.
So we
So
have
that,
some
he can
questions
have-
from the participants.
Can you hear me?
Yes, sir.
Yes, sir. Your presentation is over, Burhanuddin sir. So can we go for the question answers, or some more slides are left? Burhan sir.
Hello, can you hear me?
Yes, yes, Burhan
Yes,
sir.
yes,
Your
sir, we are
mic,
hearing
I
Okay.
think. Yeah, we are able to hear you.
Okay. Can you see my slide?
Yes, yes. The
All
data
right.
scientist slide is available. Now conclusion slide is there.
concluding slide
All
has
right.
been-
Okay. Just now I have problem with my audio. I'm sorry.
For no issue, sir. No issue.
Now,
Please continue, sir.
all right. So this is the last part of my presentation on the conclusion. First, data science research requires a certain mindset, openness for collaborations with other fields. Dealing with big data is easier than in the original variable space. Learning capabilities in data science used to discover big data variables, and then it transform the data into information. And last but not least, the information gives awareness of the relevant outstanding problems and transform them into important knowledge for decision making. And this is the references that I have in data science that I use, and probably you can have a look. And that's all my presentation. So I have been given 1 hour, so I start around 12:30, and now is 1:30. And that's all my presentation. Probably I give back to the organizer for any question and answer. Is it okay?
Thank you, sir. So we have one question from the participant.
You're most welcome.
So the question is, the participant is from material science background, material science field. So how exactly this data science help in metallurgy and material science field? This is the question, sir.
Okay. For the material science, it's talking about the material that we use for the product. Okay. So if material used for the product, let me close my slide. Okay. All right.
Right, sir.
Okay. So material, for example, we want to have like handphone, for example. Okay. Nowadays, it doesn't matter on the functionality of the handphone. Okay. We can have many smartphone. For example, in my bag, I can have two smartphone. For example, I can have a notebook. I can have two smartphone, means one iPhone and one is maybe Android based. Okay, and I can have other than that maybe I can have tabs and so on. Okay, so if you ask about the functionality of my device that I have, they're all functioning. But then now people talking about the reliability of the product that we have. Okay, for example, if I have 3 handphone in my pocket, but then if you call me, all is voicemail, then it is useless. But if I have only 1 handphone, then you call me, straight away I pick up and answer you. So it shows that I'm a very reliable, right? So there are two things: functionality and reliability. So reliability is very important. Then now, when we talk about the product, or we want to come up with the product, the material that we want to use for that product must be reliable, long-lasting, and so on. Then, if we look at the data that we have in the server, for example, the feedback from the customer on that kind of material, if we mine all those data, so we should be able to get a very good analysis what kind of material we want to use and so on. So that's basically my answer to these questions.
Thank you, sir. Thank you, sir.
Can you see me? I already changed I already stopped sharing my slide.
Your screen is blurred, sir. Like we are getting the full windows, multiple windows are visible. So
Okay.
we are not able to see you. Now, yeah. Now, yeah. I think, yeah, now we are visible.
Okay.
Yeah. Now we are visible, sir.
Sharing. Please stop your sharing.
I have to stop my sharing?
Yes, sir. No, stop your sharing. Then you will be visible.
There, bottom of the screen, you can see, sir, there is a blue button, blue ink is there. There, stop sharing is there on your screen.
Yes, sir. Now over to CRK, sir.
Okay. Can you see
Yes,
me?
yes. Any more questions, Raju? Yes, sir. You are
Yes, sir.
visible.
No, sir. That's all, sir.
Nothing else. So
Nothing else.
fine. So let me take this opportunity for the wonderful day 2 session by Dr. Burhanuddin bin Muhammad Abu Baider, sir. And
Yes, you're most welcome.
it's a pleasure, sir. It's a pleasure to have you. And you have, in fact, actually taken the audience through what do you mean by data and how to convert that particular data into knowledge, and what are the main differences and what are the collaborations between various computer science and data and analytics that is involved, differences between data scientists and data analysts. And you have taken us what is going on in the world as far as the latest applications is considered. So this session is going to be useful, I can say, for both for our undergraduate students, for postgraduate students, and also our research scholars. Thank you, sir. Thank you very much. And seeing you, I mean, looking forward for much more, many more meetings like this in the future, sir. And I'd like to thank you very much.
Okay, you are most welcome, and I would like to take this opportunity to thank Mahatma Gandhi Institute of Technology for giving me the opportunity to talk here. Thank you for Professor CRK Reddy. Thank you for Prof. Ramanamurthy and the chairperson, and all the audience, lecturers, doctors, professors, for joining me for this session, and would like to see you again in the new future. Thank you very much.
Thank you, sir. Khudafis.